Practice set 3.2, problem 3. Given the arithmetic progression 12, 16, 20, 24, find the 24th term of this progression. So we need to find the 24th term. Here, A is obviously 12, which is the first term. D, to find D, subtract 12 from 16. So that gives you 16 minus 12 is 4. So 20 minus 16 will also give you 4. So the D is 4. We have to find T24. Now we know the formula Tn is equal to A plus N minus 1D. Therefore, T24 is 12. For A, we put 12. For D, we put 4. In bracket 24 minus 1 into 4. That is 12 plus 23 into 4 is 104. Thus, the 24th term of the AP is 104. Problem 4. Find the 19th term of the following AP 7, 13, 19, and 25. This is the AP. So the first term A is 7. How do you find D? D is the second term minus the first term, that is 13 minus 7 is 6. We have to find the 19th term, that is T19. So Tn is A plus N minus 1D. So T19 will become 7, that is replacing A by 7. Bracket 19 minus 1, because this is for N is equal to 19. Multiply by D, which is 6. So 7 plus 18 into 6. 7 plus 108, that is 115. Thus, the 19th term of the AP is 115. Problem 5. Find the 27th term of the following AP. AP is given is 9, 4, minus 1, minus 6, minus 11, and so on. Here, A is 9. D is 4 minus 9 is minus 5. We have to find out T27. Same formula, Tn is A plus N minus 1D. We replace N with 27. So T27 is 9 plus 27 minus 1 into minus 5. So it comes to 9 minus 130, or T27 is minus 121. So the 27th term of the AP is minus 121. How many 3-digit natural numbers are divisible by 5? That is the problem. Problem 6. Now, 3-digit numbers are numbers starting from 100. So 100 has 3 digits, 1, 0, 0. 1000 has 4 digits. So it is less than 1000. So it will be 999. So within 100 and 999, which are the numbers which are divisible by 5? The first number which will be divisible by 5 will always be 100. So within 100 and 999, the numbers divisible by 5 will be 100. The next number divisible by 5 is 105, then 110, till we go to 995. Beyond that, 996, 997, 998, 999 will not be divisible by 5. So 995 is the final number which is divisible by 5 up to 1000. Now the given sequence is an AP where A is equal to 100, B is equal to 5, and the last term Tn is 995. Now we want to know what is the value of N here. Once we know the value of N, we know there are how many 3-digit natural numbers are there, because N will be the number of natural numbers which are divisible by 5. So Tn value is 995. We need to find N. Same formula, Tn is A plus N minus 1D. So 995 is 100 plus N minus 1 into 5, because D is 5. 100, 105. If you minus it, it comes to 5. So 100 plus 5n minus 5. So once you remove 100, bring it to this side, it becomes 895 is 5n minus 5. Bring 5 here, It becomes 895 plus 5 is 5n, or 5n is 900. So n is 900 by 5, or n is 180. So that means there are 180 three-digit natural numbers which are divisible by 5. Problem 7. The 11th term and the 21st term of an AP are given. They are 16 and 29. Find the 41st term of the AP. If you know the value of A and the value of D, you can find any term. You can find the 41st term. So from these two values which are given, you have to find the value of A and D. Now T16, T11's value is 16 and T21's value is 29. You have to find T41. Now Tn is A plus n minus 1D. So T11, which is 16, is A plus 11 minus 1 into D, that is A plus 10D. Therefore, A plus 10D is 16. Similarly, T21 is A plus 21 minus 1 into D. So 29 is A plus 20D. A plus 20D is 29. Now what you can do is, so now you have two equations and two variables. Variables are A and D, and you have two equations, equation 1, equation 2. So we can easily solve this equation to get the value of A and D. Subtracting 1 from 2, so A will get cut. So you get A plus 20D is 29, A plus 10D is 16. So when you minus this equation from this one, A will get cut. 20D minus 10D, it becomes 10D. 29 minus 16 becomes 13. So D is 13 by 10. Now to find A, we just substitute the value of D 13 by 10 in one of the equations. If you're substituting in equation 1, A plus 10D is 16. So A plus 10 into 13 by 10 is 16. So becomes A is 16 minus 13, or A is 3. Now we have A is 3. We have D is 13 by 10. We need to find T41. So T41 is A plus, this is the formula, A plus n minus 1D. For A, we put 3. For D, we put 13 by 10. And here, 41 minus 1 is equal to 3 plus 40 into 13 by 10. So 10, if it cuts it, it becomes 4. So 3 plus 4 into 13. 3 plus 3, if 3 plus 52. So T41 is 55. The 41st term of the AP is 55. An AP is given, problem 8, 11, 8, 5, and 2. In this AP, which term is the number minus 151? So we need to find n. Tn is given as minus 151. This is AP. So A is 11. D is T2 minus T1. It is 8 minus 11 is minus 3. We need to find the value of n. When the value is given as 151, we need to find the value of n. What is n? So Tn again, same formula, is A plus n minus 1D. So minus 151 is 11 plus n minus 1 into minus 3. Minus 51 is equal to 11. Opening this bracket, minus n, minus 3 into n is minus 3n. Minus 3 into minus 1 is plus 3. So it comes plus 3. Minus 151 is 14 minus 3n. So you bring 3n here, you take this term here. So 3n is 14 plus 151. 3n is 165, or n is 55. Problem 9. In the natural numbers from 10 to 250, how many are divisible by 4? We have solved a similar problem before. When divisible by 5, we had to find how many numbers are divisible by 5. Now the numbers between 10 to 250, we need to find how many are there which are divisible by 4. The sequence, between 10 to 12, the numbers divisible by 4. The first one would be 12. So 10 is not divisible by 4. 11 is not. 12 is. So we start with 12. The next number divisible by 4 is 16. Then 20. And up to less than 250, the numbers. 250 is not divisible by 4. 249 is not divisible. 248 is divisible. So we put 248 here. So how do we do it? From 10, 10 is not divisible by 4. 11 is not divisible. 12 is divisible. So we put 12 as a first term. At the last, 250 is not divisible by 4. 249 is not divisible. 248 is divisible. So we put 248 here. And then 12, the next number which is divisible by 4 is 16. So this is the sequence and up to 248. So A is 12, B is 4. Now Tn is 248. We need to find N. Same way, 248, Tn is A plus N minus 1D. So 248 is 12 plus N minus 1 into 4. We bring 12 here, 248 minus 12 is 4N minus 4. Take 4 this side, so 236 plus 4 is 4N. 4N is 240. So N is 60. There are 60 natural numbers from 10 to 250 which are divisible by 4. Problem 10. In AP, the 17th term is 7 more than its 10th term. Find the common difference. So T17 is T10 plus 7. You have to find D. So Tn is A plus N minus 1D. So T17 is A plus 17 minus 1 into D, that is A plus 16D. T10 is A plus 10 minus 1 into D. So it becomes A plus 9D. Now T17 is T10 plus 7. So A plus, replacing the values of T17 from here, A plus 16D is T10. T10 is A plus 9D plus 7. So A gets cut. 16D minus 9D you get 7D. So 7D is 7. So D is equal to 1. The common difference is 1. Now we have been studying arithmetic progression. In geometric progression, there is a different kind of a method there. In geometric progression, what happens is T2 upon T1 is constant. T3 upon T2 is constant. So Tn upon 1, Tn plus 1 upon Tn is a constant number. But we will not be studying geometric progression now. How do you find the sum of the first n terms of an AP? We know how to calculate the nth term, that is Tn is A plus N minus 1. How do we calculate the sum of terms till Tn? So Sn is the sum of all terms till Tn, that is A plus D plus so on till A plus N minus 1D. The method to find out the value of Sn is you reverse the order. So from here is A to A plus N minus 1D. Now what you do is you bring first A plus N minus 1D and then bring all the terms. A minus N minus 2D is brought here and so on and so forth. And the last terms will be A plus D and A. When you do that, now when you add these in order, so we have 2Sn when you add these two. And when you add this and this, the value becomes 2A plus N minus 1D. When you add this to this. When you add this term and this term, the value again becomes 2A plus N minus 1D. At the end, if you add this, it again becomes 2A plus N minus 1D. So 2Sn is equal to 2A plus N minus 1D n times. Okay, n times 2A plus N minus 1D is equal to n into 2A plus N minus 1D. Therefore, Sn is, so 2Sn is n into 2A plus N minus 1D. So Sn is n upon 2, 2A plus N minus 1D. So this is the formula for calculating the sum of all terms in an AP. Here is an example. Find the sum of the first 100 terms of an AP 14, 16, 18. Here A is 14, the first term. D is 16 minus 14 is 2. First 100 terms is n is 100. The formula is Sn is n by 2, 2a plus n minus 1d. So n is 100, a value is 14, d is 2. So we can calculate easily. So S100 is 100 upon 2. 2 into 14 plus 100 minus 1 into 2. So total value comes to 28 plus this is 99. 100 minus 1 into 2 is 198. 28 plus 198 is 226. So 50 into 220 is 11,300. Sum of the first 100 terms of a given AP is 11,300. So let us remember, Tn is a plus n minus 1d. Sn, the sum of all terms of the AP, is n by 2 into 2a plus n minus 1d. Also, there is one more formula for calculating Sn. In an AP, these are the terms. First term is a and nth term is a plus n minus 1d. Now, we can also break up this formula. Sn is n by 2 into 2a plus n minus 1d. You can make it as a plus n minus 1d. But a plus n minus 1d is Tn. So Sn is also equal to n by 2 bracket T1 plus Tn. This is another formula to calculate the series, the sum of the AP. You need to know the first term, you need to know the nth term, and you need to know the value of n. This is solve problems in the textbook. Example 1. Find the sum of the first n natural numbers. In the first n natural numbers, you start with 1, 2, 3, and going up to n. Your a is 1, d is 1, 2 minus 1 is 1. And the nth term is n. So you can have Sn is n upon 2, first term plus the last term. So this is the Sn. Adding all these terms, 1 plus 2 plus 3, going up to n. First term is 1, last term is n. So Sn is n upon 2, first term plus last term. It is n upon 2, 1 plus n. That is n into bracket n plus 1 upon 2. The sum of the first n natural numbers, remember, is n into bracket n plus 1 upon 2. Find the sum of the first n even natural numbers, even numbers. So these are, so like the numbers will be 2, then 4, then 6, up to the first n even numbers. So you need n numbers. So that means it will be 2n. So the last number will be 2n because you are looking at first n numbers. So this will be, say 2 is one first number. This is second number. You need n numbers. So this is the last number will be 2n. T1 is the first term is equal to 2. Tn is the last term is equal to 2n. And d is 4 minus 2, 6. This is 4 minus 2 is 2. Very easy to calculate. First method, n by 2 T1 plus Tn is 2 plus 2n into n by 2 becomes n bracket 1 plus n. In method 2, Sn is 2 plus 4 plus 6 up to 2n. So you take out 2. So the bracket becomes 1 plus 2 plus 3 up to n. And we have calculated this in the previous problem that the value is n plus 1 upon 2. So again, finally, the sum of the even first n even numbers becomes n 1 plus n. Method 3, using the normal formula. N by 2, 2a. A is 2. So 2 into 2 plus n minus 1 into d, which is 2 again. So 4 plus 2n minus 2 is 2 plus 2n. So this 2 gets cut. You can take out 2 here because it's common. And then here there is 2, so that gets cut. So 2 and 2 gets cut. So it becomes n into 1 plus n. Example 3. Find the sum of the first n odd natural numbers. Solution. The first n natural numbers are 1, 3, 5, 7, and so on till 2n minus 1. So the first term is t1 is equal to 1, and the last term is 2n minus 1. And the d will be 2. So the methods are to solve it. First, using method 1, Sn is equal to T1 in the last term. So the last term is 2n minus 1. First term is 1. So Sn is n by 2. 1 plus 2n minus 1. So minus 1, 1 gets cut. So it is 2n. So n upon 2 into 2n, that is 2 gets cut. So it is n square. Method 2, using the formula, n upon 2 is 2a plus n minus 1d. 2 into 1 plus n minus 1 into 2. So again, we come to n square. Method 3. 1 plus 3 plus 2n minus 1. So this plus, this is the 1 plus 2, 1, 2, 3 till 2n will be the series of all the numbers. You will be minusing the value in brackets of the even number, the sum of the even numbers. So you take the sum of all the numbers up to 2n minus the sum of the even numbers up to 2n. Then you get the sum of the odd number. So we know from formula, the sum of all the numbers up to 2n is 2n into n, 2n plus 1 upon 2. And we also know previously from previous examples that the sum of even numbers to 2n is 2n n plus 1 upon 2. So once you subtract that, you get the value n square. Now we go to example 4. Find the sum of all odd numbers from 1 to 150. So the odd numbers are 1, then you have 3, 5, 7 till 149, because 150 is not an odd number, 149 is. This is the series. Your A is 1, D is 2, because 3 minus 1 is 2, so odd numbers. So there will be a difference of 2 between them. Let us find how many odd numbers are there from 1 to 150. So the Tn is 149. So Tn is A plus n minus 1D. 1 plus n minus 1 into 2. 149 is 1 plus 2n minus 2. So n is 75. Now find the sum of these numbers. Because now we know n is 75, we can use formula. We know n is 75, we know A is 1, we know D is 2. So you can easily find the value of Sn. So using both methods, method 1 using the direct formula, Sn is n upon 2, 2a plus n minus 1d. A is 1, so 2 into 1 plus 75 minus 1 into d. D is 2. That becomes 2 plus 75 into 2 minus 2. 1 into 2 is 2. So 2 gets cut, so it becomes 75. So 75 upon 2 into 75 into 2. So that the 2 gets cut, so it becomes 75 into 75, which is 5625. The second method is T1 plus Tn into n upon 2. First term T1 is 1. The last term is 149. So Sn is 75 upon 2 into bracket 1 plus 149. 1 plus 149 is 150. So it is 75 upon 2 into 150. 5625. Now practice set 3.3, problem 1. The first term and difference are given. Find S27. A is 6, D is 3. We have to find S27. So we put it in the formula. Sn is n upon 2, 2a plus n minus 1d. A is 6. So 2 into 6 plus, now n is 27. Given S27. You want to find the sum till the 27th term. So 27 minus 1 into d. D is 3. So 27 upon 2 into plus into bracket 12 plus 27 minus 1, that is 26 into 3. That becomes overall, this becomes 90. 27 upon 2 into 90, it is 27 into 45, which is 1215. Find the sum of the first 123 even numbers. So n is given, 123 even numbers. So the even numbers start from 2, then 4, 6, 8, so on, till 123 numbers. We want to find their sum, that is Sn. So A is 2. The difference 4 minus 2 is D is equal to 2. And the N is given as 123. So Sn is N upon 2 bracket 2A plus N minus 1 into D is equal to 123 upon 2 bracket 2 into 2 plus 123 minus 1 into 2. That comes to 123 upon 2 bracket 4 plus 122 into 2. That is 4 plus 2, 44 into 123 upon 2. 123 upon 2 into 2, 48. So 2 divided by 248 is 124. So 123 into 124, that becomes 15252. First, the sum of the first 123 even natural numbers is 15252. Problem 3. Find the sum of all even numbers between 1 and 350. So 350 is also an even number. Between, they've said between. Okay, so this does not include 1 and 350. You want to find in between. So 350 is not an even number. So the last term will be 348. Before 350, the last even number is 348. And after 1, the first even number is 2. So remember, the question is in between. They have not said from to this number to that number. So the series is 2, 4, 6, 8 till 348. Now A is 2, first term. D is 4 minus 2, that is 2. And Tn, the last term is 348. So first we find Tn. Tn is A plus N minus 1D. So 348, the value of Tn is 348, is 2 plus N minus 1 into 2. Bring 2 here, so this becomes 346. 2 into N, so it becomes 2N minus 2. So 2N minus 2 is 348 minus 2. That is 346 is 2N minus 2. Again, take 2 this side. 2N is equal to 346 plus 2. That is 348. So N is 348 by 2. N is 174. Now we know this is the Tn. Now we know the value of T1 and we have given the value of the last term, that is 348. So it's easy to calculate. We know N. N is 174. So Sn is N upon 2 T1 plus Tn. Is 174 upon 2 bracket 2 plus 348. 2 plus 348 is 350. That comes to a value of 30450. As the sum of even natural numbers between 1 to 350 is 30450. In an AP, the 19th term is 52 and the 30th term is 128. We have to find the sum of the first 56 terms. So from this conditions, 19th term is 52, 30th term is 128. We have to find the value of A and D. They have given N, that is first 56 terms. Once we know A and D, we can calculate the sum, Sn. So Tn formula is A plus N minus 1D. So the 19th term, the value is 52. 52 is equal to A plus N is 19. 19 minus 1 into D. So that is A plus 18D. So A plus 18D is 52. Now the 30th term, that is 128, is equal to A plus 38 minus 1 into D, because in this case it is T38. 38 minus 1. So A plus 37D is 128. So we have A plus 18D is 52. A plus 37D is 128. Now we can easily find A if you minus this equation from this. you can get the value of D, and then you replace it into this equation and you will get the value of A. But if you add both of these, what we find is it becomes 2A plus 55D, and the value is 180. Now they have said they want to find the sum of the first 56 terms. So once you have 2A plus 55D, you know that Sn is n upon 2A plus n minus 1D. So now 55, you want S56. So this 2A plus 55 comes here. The entire thing becomes 2A plus 55D. So for when S is 56. So S56 becomes 56 upon 2 into this entire thing, which we have calculated the value as 180. So 28 into 180. So S56 is 5040. The other way to do that is you solve these two equations to get the value of A and D. Once you know that, you can easily put it in the formula, this formula, and you will get the value of Sn. Problem 5. Complete the following activity to find the sum of natural numbers between 1 and 140, which are divisible by 4. It is again between. So 1 and 40 doesn't count. It should be numbers between. From 1, which are divisible by 4. 1 is not divisible, 2 is not divisible, 3 is not divisible, 4 is divisible. So first number will be 4. After that, the next number will be 8, and so on. And 140 less than 140, 139 is not divisible, 138 is not divisible, 137 will not be divisible, 136 will be. So last number is 136. So the series is 4, 8 up to 136. Now you can calculate the numbers. We have calculated and given n is 34. N is 34, A is 4, D is 4. So Tn is, how they have done that to calculate n is 34? Tn is 136. That is A plus n minus 1D. A is what? 4. D is 8 minus 4 is 4. So 136 is 4 plus n minus 1 into 4. So from that, when you calculate, you get n is 34. Now Sn is this formula. So you put the number here. So S34, n is 34. So you want to find the number of all these numbers, sum of all these numbers. So the sum is S34 is 34 by 2. 2 into 4 plus 34 minus 1 into 4, which comes to 2380. How do you solve it? First, you find out the series. Then you know that Tn is this formula. So you calculate the value of n. Once you know n, once you know A, once you know D, you just put it into Sn and you get the value. Problem 5. This is the working of the previous problem. A is 4, D is 4, Tn is 136. So Tn is A plus n minus 1D. That is 136 is 4 plus n minus 1 into 4. When you solve that, you get n is 34. And in S34, you put the values to get the values of A, D, and the value of n. And you get 2380. Sum of the first 55 terms in an AP is 3,300. Find its 28th term. So they have given n is 55. The value of the Sn is 3,300. So n is given, Sn is given. You have to find the 28th term. To find the 28th term, we need A and D. So somehow from this, we are supposed to calculate, because the value of Sn is given, A and D. Now Sn is n upon 2 upon 2A plus n minus 1D. Now n is given, first 55. And S value is given. S55, the value is 3,300. So n is 55 and this value is 3300. So 50, it becomes 55 upon 2a plus 54 into d. Now, you have been asked to find the 28th term. Once you divide this 2a plus 54d by 2, what happens is a plus 27d. What is a plus 27d? It is t28. You remember, t28 is a plus n minus 1d. So t28 is a plus 27d. So this becomes t28. So 3300 is equal to 55 upon 2 into 2 into t28. So t28 is 3300. You divide this by 55. So that comes to 60. So this is t28 is 60. The t28 is 60. Thus the 28th term is 60. Practice set 3.3, problem 7. Sum of 3 consecutive terms is 27 and their product is 504. Find the terms. Assume the 3 terms are a minus d, a, and a plus d. So we will assume the 3 terms. There are 3 terms of an AP. The sum is given as 27. So let us assume that is a minus d, a plus d. So we know that this is the way this will be the AP because a minus d, the difference is d. A plus d minus a, the difference is d. So this is following in an order. Now the sum is 27. So we add the 3. When we do this, a minus d plus a plus a plus d. So d and d gets cut. So what will remain is 3a. 3a is 27. So a is 9. Now we need to find d. Now the product of all the 3 terms is 504. So a into d into a plus d is 504. A square minus d square into a is 504. Because a minus d into a plus d is a square minus d square. Now we know a is 9. So we substitute the values. So 9 square minus d square into 9 is 504. So 9 square is 81. 81 minus d square is 504 upon 9. That is 56. We bring 8 d square here and bring 56 here. So d square is 81 minus 56 is 25. Therefore, d is plus and minus 5. So either d can be plus 5 or d can be minus 5. When d is plus 5, a is given as 9. So the terms will be, first term will be 9. 9 minus d. So d is 5. So 9 minus 5 is 4. So the first term will be 4. Second term will be a, which is 9. Third term will be a plus d, that is 14. When d is minus 5, a is 9. So the first term is 9 minus 5. Minus into minus 5. Minus and minus becomes plus. So it becomes 14. Second term is a. Third term is a plus d, that is 9 plus minus 5, that is 4. So the required terms are either 4, 9, 14 or 14, 9, 4. There are 2 sequences. Find 4 consecutive terms in an AP whose sum is 12. And sum of the third and fourth term is 14. Now let us assume that the 4 consecutive terms are a minus d, a plus d, and a plus 2d. So they follow in order. A minus d, then after that a, then a plus d, then a plus 2d. So these are the 4 consecutive terms. A plus a minus d, a plus d, and a plus 2d. The sum is 12. So if you add this up, you get 4a plus 2d is 12. Or 2 into bracket 2a plus d is 12. So 2a plus d is 6. Now sum of the third and fourth term is 14. Third and fourth term, when you add a plus d plus a plus 2d is 14. That is 2a plus 3d is 14. So now you have 2 equations. Equation 1, 2a plus d is 6. Equation 2, 2a plus 3d is 14. Now we can easily find the factors a and d. So 2a plus d is 6, 2a plus 3d is 14, and when you minus this, you get, this gets cut. So d minus 3d is minus 2d. 6 minus 14 is minus 8. So d is minus 8 by minus 4, minus 2. So d is 4. Now to get the value of a, substitute d is 4 in the first equation. So 2a plus d is 6. So you get 2a plus 4 is equal to 6. So a is 1. As the required terms are a minus d, that is 1 minus 4, that is minus 3. Second term is 1, that is a, then a plus d is 5, a plus 2d is 9. Problem 9. If the ninth term of an AP is 0, then show that the 29th term is twice the 19th term. Given T9 is 0, we have to prove T29 is 2 times to T19. That is T29 minus 2 into T19 is 0. Proof. Now Tn is a plus n minus 1d. So T9, which is the value of 0, is a plus 9 minus 1d. So 0 is 8a plus 8d. Okay, because the value of T9 is given. Now T29 is a plus 21 minus 1d. That is a plus 28d. And T19 is a plus 18d. So if you minus T29 minus 2 times 2 T19, it becomes a plus 28d minus 2 bracket a plus 18d. That becomes a plus 28d minus 2a minus 36d, or minus 8 minus 8d. If you take the minus sign outside, minus bracket 8, a plus 8d. But this a plus 8d is 0. So it becomes 0. Therefore, T29 minus 2 times T19 is 0. So T29 is 2 into T19.